Okay, we're back here. Let's look at example number 3. And so it says that in this picture, the length of AB is 12, the length of CD is 8. What is the radius and the diameter of the circle? Now, one thing about this, notice that they have drawn a radius for us. If they don't draw one, then you can make one. You're allowed to draw one. And the idea is you want to draw it in a way that gives you a right triangle, which they give you. All right, so let's label what we know here. They say AB is 12. Now AB is the chord. So that whole thing, that distance there, is 12. The length of CD is 8. What is the radius? So we're looking for R. Now let me zoom in a little bit here. Okay, now, the problem is we'd like to use Pythagorean theorem, but we don't know the length of AD. Not yet. However, what you have here is a situation where C is part of a diameter. If you were to extend this segment, you'd have a diameter. It is perpendicular to the chord because you have a 90-degree angle for AB. So what happens, we know that if a diameter is perpendicular to a chord, it bisects the chord. So this and this have to be the same. So if the whole thing, AB, is 12, then this length here is 6. And so what that gives us now, we can do Pythagorean theorem. The hypotenuse is the radius, is R, because it's opposite the 90. So 6 squared plus 8 squared equals R squared. 36 plus 64 is equal to R squared. That adds up to 100. The last step to solving this equation, to undo a square, you have to square root both sides. So 10 equals R. Now 10 is the radius. They also ask for the diameter of the circle. Well, take the radius and double it, and you get the diameter. So 20 equals D. Now we'll come back to this last theorem at the bottom, but before you do that, flip your notes onto the back. Now these are the notes that you're going to take tomorrow as well. We're going to talk about tangents, but we're only going to do one problem on this. We have one more example, and it's problem number 8. A chord is 10 inches long and 12 inches from the center of the circle. Find the length of the radius. All right, so here's what we'll do. I'm going to draw a circle. Now you can use the compass, but you don't need to. Let's just freehand it. We just need a picture of a circle. And it says the chord is 10 inches long. There's a chord. And it's 12 inches from the center. When you talk about distance, you're talking about a perpendicular. So if they say it's 12 inches from the center, 12 inches is going to be your perpendicular here. Okay? That's the distance. Now it says find the length of the radius. Well, let's go ahead and draw it. Let's draw it, and now we create a right triangle by doing it like this. Okay, so we have, this is 12. The hypotenuse is R, that's the radius. Now they said the chord was 10 inches long, so this whole thing is 10. Well, that means that this piece here, because it gets bisected, the chord gets bisected, that's going to be 5. So now we can do Pythagorean theorem. A and B are the legs, so we can say 5 squared plus 12 squared is R squared. You get 25 plus 144 equals R squared. That adds up to 169. Take the square root of both sides, and we get 13 inches is the radius. 13 inches is the radius. Okay, so that's how you do number 8. You draw the circle, create the relationship. You're looking for right triangles. When you have a right angle, you're looking for right triangles. Okay, go back to the front, and we'll look at the last part of the notes here, this last theorem. Let me zoom out a little bit. In a circle, or in congruent circles, two chords are congruent if and only if they are equidistant from the center of the circle. Okay, for this one, I'm going to freehand this again. No, actually, let's use the compass. Let's use the compass and get ourselves a good circle. So there's a center. I'm going to make it small again. All right, that's a good looking circle. If we have two chords, all right, I'm going to make these congruent. So let's see, how am I going to do that? I'm going to make them so they're 2.5 centimeters. So I'm just going to pick a place, pick a point on the circle. There's a point, and let's measure 2.5. I'll use the ruler for this. So I can just turn this until it gets to 2.5. So right about there is my point, so I can draw it. So there's a chord. And then I'm going to draw the same chord somewhere else. Let me do it up here. Let me pick another point. So there's a point. And let's make the chord 2.5 right about there. Okay, so there's AB. Let's call this CD. Now, assuming that these are congruent, all right, and I think they are the way I measured them. I might be off a little bit. Yeah, 2.5. That's a little bit short. Okay, that's okay. If we draw the distance from the center, now distance is a perpendicular. Distance is always 90 degrees. So if we do that, if the chords are congruent, so if segment AB is congruent to segment CD, then what we can also say, let's call the center point P, and then let's call these points here where the distances hit the chords, let's call these E and F. If the chords are the same, then these two distances have to be the same. So then we can say that PE is congruent to PF. Okay? So we would be able to say that those would have to be congruent to each other. Now the other thing that you know is that if the chords are congruent, anything from the center that's perpendicular, it's going to bisect. So you know those are the same. You know that these are the same. All those pieces are going to be congruent to each other. And the other thing that we could say, going back to the first theorem here, is that these arcs are also congruent. So there's a lot of information there. Okay, that is it for your notes for today.